Now, so part C here by means of partial fractions, right? So see, it says partial fractions. That's a wee hint. We're going to get the integral of this thing here. So if we look up the exam papers, the back of the exam papers, we'll see something like this. I'm going to add in an image here now, and this is a formula for integration by partial fractions. Right, so that's going to be the key to cracking this one. So we're going to write our original structure here in this form here, to the right of the equal sign. So looking at this on the left hand side, for us m equals 2 and n equals 1, and plus c there, see that, plus c or c equals minus 3, right? C equals minus 3. So we can rewrite this guy. So we have 2x plus 1 all over x minus 3 all to be squared equals some big A, capital A, we don't know that one yet, over x plus c, but c is minus 3 and plus minus 3 is just going to be minus 3, plus b over x minus 3 all to be squared. And now our job is to figure out a and b. So what we can do here, I'm just going to change colour to black, we can multiply all across this here, all across this equation by x minus 3 all to be squared. So I could stick in up here x minus 3 all to be squared, and I can stick it in up here x minus 3 all to be squared, and I can stick it in here x minus 3 all to be squared. So I've multiplied all across by the same number, so the equals, the left side still equals the right hand side. And now we can do some cancelling. So I'll shift to green here. So on top here we have x minus 3 all to be squared, and we have the same structure underneath. So those guys will cancel there. And over here on the very right hand side, b times x minus 3 all to be squared on top of x minus 3 all to be squared. Those will cancel there. Here we have x minus 3 all to be squared, but down here we just have x minus 3. So that's going to be like on top x minus 3 times x minus 3 all over x minus 3. So we'll cancel, one of them will cancel, and we're left with x minus 3 on top. So that'll cancel, and that 2 will disappear effectively. So I'm going to rewrite that now in black. So now we have 2x plus 1 equals a times x minus 3 plus b times nothing, actually, because it's all cancelled, so I can just undo that last mark there. Right, so this is what we've boiled down to now. So our next step, in red, I'm going to stick it in, we're going to set x. We're going to, for the crack, we're going to say x equals 3. So when x equals 3, this guy here will go to 0. It'll be a multiplied by 0. Because 3 minus 3 is 0. So when x equals 3, we'll have 2 times 3 plus 1 equals a times 3 minus 3 plus b. And that'll become 2 times 3 is 6, plus 1 will be 7 equals, and a will be multiplied by 0, because 3 minus 3, do what's in the brackets first, 3 minus 3 is 0, 0 or a times 0 is just 0, so 7 equals b, or b equals 7. So we have figured out our value for capital B, or big B. Now, when b is 7, we can go back to this guy here, this equation marked with a star, pretty poor star anyway, and we can set b to 7. Right, so we're going to use that equation again. So we have 2x plus 1 equals a times x minus 3 plus 7. And then we can do some tidying up. So what I'm going to do now is I'm going to subtract 7 from both sides, right? Just write it in there to show what's going on. And 2x plus 1 minus 7 results in 2x minus 6 equals a times x minus 3. Now I'm going to change to blue and start up here again, and what I'm going to do is I'm going to pull the 2 out of the left hand side. So I'm going to have 2 times x minus 3. So I've changed the structure of the left hand side, but it's identical in value. I've just factored out the 2 equals a times x minus 3. And now we see that there's an x minus 3 on both sides. So we can divide both sides by x minus 3. Right, that'll work out well for us. We divided by the same amount on both sides, so that's okay. We're still equal here. They'll cancel out here, and they'll cancel out here, and we'll be left with 2 equals a. I'll just scrap that 2 there, right? Tidy it up. 2 equals a. So now we have a equals 2. And b equals 7. So I'm just going to make some space here now. Alright. What about this stuff? Now, what are we going to do? Right, back to the pen. So we can rewrite our original integral 2x plus 1 over x minus 3 all to be squared. We can now write that down as the integral of a, which is 2 over x minus 3, right, plus b, which is 7 over x minus 3 all to be squared. And we can stick on a dx here in the end, right? So I'm just going to get rid of this, get rid of that. And now we just integrate this, so that's the same as 2 separate integrals. So we could write in an integration sign in here, and we could have a dx in there as well if we want, right? So that's equal to 2, we can bring out the 2. It's the integral of x plus 1 over x plus 3 dx plus 7 times the integral of 1 over x minus 3 all to be squared dx. Now with the second one, I'm going to actually rewrite that. I'm going to rewrite that like so. I'm going to bring up the x minus 3 above the line, and then the power changes sign, so we get minus 2. And now they're more easy to integrate. There's no point bringing this one here above the line, because that doesn't suit us. We can't integrate when the power is minus 1. So the rule here, if we look up in the back of the exam sheet, we're going to get 2 times the natural log. Yo, how's it going? X plus 3, right? 2 times the natural log of x plus 3. And then we're going to integrate the second one, 7 times the x minus 3. Add 1 to the power. Minus 2 plus 1 gives us minus 1. And we write it, is that right? Minus 2 plus 1 is minus 1. And we write the whole thing over the new power, which is going to be minus 1. And then we do a little bit of tidying up. So we have 2 ln x plus 3. And then 7 over minus 1 gives us minus 7 times x minus 3 to the power of minus 1. And we can further tidy that up. We want to get fancy. We can bring the 2 up and we'll have ln x plus 3 ought to be squared. The 2 can jump up there. And then we're going to have minus 7. And we can write that over, bring the x minus 3 below the line. And the power becomes positive, so it's the power of 1. You can put the 1 in or leave it out. And don't forget lastly to add on big C for the constant of integration. And that's it done.